Integrals. Integral is the space or area under a curve. It is the opposite of a derivative. Isaac Newton and Leibniz recognized the relationship between the integral and derivative, establishing the fundamental theorem of calculus. Integrals can be applied to real life in a variety of ways such as physics, engineering, and chemistry. For today, we will be focusing on how integrals can be applied for a physicist and a civil engineer. In this problem, we're trying to find the mass of a thin wire with the linear density function p of x equals x times 4 minus x in kilograms over meters on the interval 0 to 4. The formula for mass equals linear density times length. The density is x times 4 minus x, and the change in x is the length as it is giving us the width of the section. This gives the mass for one slice. However, we want the mass of the whole wire, so we need to take the integral as we have to add up all the sections up, and this is the most accurate way. So the integral, the change in x is dx, and we want to start from 0 and end at 4, so that would be the limits. And then we'd integrate using the pi rule and plug in the limits using the fundamental theorem of calculus, and the steps are shown in the notes. In engineering, corrugated iron is used as a building material, so integration can be used to find out how wide the flat sheet should be. In this, find the width of the corrugated iron sheeting for the building of the aquarium, given that y equals 1 plus 6x to 3 over 2 power from 0 to 1. The formula is integral of the square root of the derivative squared plus 1. So first, take the derivative of 1 plus 6x to 3 over 2 power and square this to get 81x. Next, plug this into the arc length equation, and the limits are from 1 to 81 as there are limits given in the problem. So for u substitution, the original limits are plugged in for x and solved for u. So here we would use u substitution as there is the square root, and u is what is under the square root, which is 1 plus 81x. Then take the derivative to get 1 over 81 du equals dx. As that is the constant, put the 1 over 81 in front of the integral and put a u for what was substituted for it. Then use the power rule to integrate and use the fundamental theorem of calculus to plug in the limits, ending with 6.103 as the answer.